Look at this barn. It's over 200 years old. No architect designed it. No engineer ran the numbers. No one poured concrete or used a single power tool to build it. And yet, this barn keeps animals warmer in the winter, cooler in the summer, and drier all year round. Better than most barns being built today with modern materials. It does this without electricity, without insulation in the walls, without HVAC, without vents, without a single moving part. The secret isn't in the wood, or the stone, or even the paint. The secret is where they put it. They built it into a hill, and once you understand why, you'll start noticing this design everywhere across the American countryside. And you'll wonder why almost nobody builds this way anymore. This is the story of the bank barn, one of the smartest pieces of vernacular architecture ever built in America, and the reason it's quietly disappearing. Here's the basic idea, and it's almost embarrassingly simple once you see it. Find a hillside, build your barn right into the slope. Now you have two ground-level entrances, one at the top of the hill, leading into the upper floor, and one at the bottom of the hill, leading into the lower floor. No ramps needed, no stairs needed, no machinery needed to move a 2,000-pound wagon load of hay up to the second story. You just walk the horse and wagon up the natural slope of the land, right through the door, onto the upper floor. This style has a name, the bank barn. Bank here doesn't mean a financial institution. It means the bank of earth that the barn is built against, the same word used for a riverbank or the bank of a hill. The most famous version of this design is called the Pennsylvania barn, sometimes called the Pennsylvania Dutch barn. It's a type of bank barn built in the United States from roughly 1790 to 1900. Its defining feature is something called a forebay, a section where the upper wall actually overhangs the foundation below it, like the building is leaning slightly out over the lower level. We'll come back to why that overhang matters, because it's not decoration, it's doing real work. The design wasn't invented by the Amish. It traces back to bank barn traditions in England, Switzerland, and Germany, going back to at least the 1660s, in places where farmers were already dealing with steep, uneven land. When German and Swiss settlers came to Pennsylvania, they brought the design with them, and it found a second home here. Because Pennsylvania, it turns out, has exactly the kind of rolling, hilly terrain this design was made for. What the Amish and Pennsylvania Dutch communities did wasn't invent the bank barn, it's that they perfected it, mass-produced it across the countryside by the thousands, and, critically, they're some of the only people in America still building and maintaining them exactly the way their great-great-grandparents did. Let's actually get into why this design is so clever, because it's solving about 4 problems at once, and most modern buildings only solve one. Problem 1. Moving heavy things, uphill, is hard before tractors, before forklifts. The way you got a full wagon of hay or wheat up to a second story was a serious labor problem. The bank barn solves it by using the hill itself as the ramp. Wagons could be pulled up to the second floor level using the slope of the hill as an access ramp. You're not building a ramp. The earth already built it for you, for free, 10,000 years ago. So, a farmer drives a horse-drawn wagon, loaded with hay or sheaves of wheat, straight from the field, up the natural slope, and right onto the upper threshing floor of the barn. No lifting, no pulley system needed for the heavy stuff. Just gravity working in your favor instead of against you. Problem 2. Animals need a controlled climate without burning fuel. This is the part most people miss. The lower level, where the cows, horses, and other livestock live, is set into the earth on at least 1 or 2 sides. The lower level often functions essentially as a stable level set into the hillside, with the ground itself acting as a wall. Why does that matter? Soil a few feet down stays remarkably stable in temperature, regardless of what's happening outside. It doesn't swing wildly with the weather the way air does. So, a barn with 1 or more walls bermed into a hillside is getting passive insulation from the ground itself. No foam, no fiberglass, no spray insulation, just dirt doing what dirt does. In winter, that earth wall keeps the worst of the cold out. In summer, it keeps the stable level noticeably cooler than the open air. The animal's own body heat does the rest of the work, keeping the space warm in winter. Heat that, in a barn with thin walls fully exposed to wind on all sides, would just escape. Problem 3. Gravity should work for you, not against you. Look at the layout again. Animals on the bottom, hay, grain, and feed on top. That's not random, that's a feeding system. Farmers stored grain and hay on the upper floor and housed animals on the lower floor, which meant feed could simply be dropped down through openings in the floor to the animals below. You're not carrying heavy buckets of feed up a ladder. You're using gravity to deliver it down. Manure management often worked the same way in reverse in many versions of these barns. A basement level beneath the stable area could function as a manure collection zone, again using gravity to move the heaviest, least pleasant material with the least amount of human effort. Problem 4. The forebay, the overhang that does triple duty. Remember that overhanging upper wall I mentioned? The forebay is a cantilevered overhang that projects out over the eave side of the ground level. Here's what it actually does. It shelters the lower level doors and the animals from rain and snow, since they're tucked back under cover. It creates extra protected space, sometimes for equipment, sometimes for animals to stand out of the weather without leaving the barn footprint. Structurally, it lets the builders add upper floor storage space without making the building wider at the base, which matters when stone and timber are expensive and land is the one thing you don't want to waste. It's a tiny architectural detail, but it's solving a weatherproofing problem and a storage problem with the same 6 feet of overhanging floor. Now, let's talk about how these things were actually constructed, because the materials tell their own story. The foundation and the lower stable level were almost always built from stone, fieldstone, pulled right out of the farmer's own fields while clearing land for crops. That's not a stylistic choice. That's recycling literal obstacles into a building material. Every rock a farmer dug out of his field, while plowing became part of the wall, keeping his livestock warm that winter. The upper level, the timber frame, was typically built using mortise and tenon joinery. No nails holding the main structure together. Wooden pegs and interlocking joints, cut by hand, that locked the frame together under its own geometry. The specific patterns of how these joints were cut can actually tell historians which ethnic building tradition built the barn, and roughly how old it is. German joinery looks different from English joinery, and craftsmen pass these exact techniques down for generations. And then there's the part of barn construction most people have actually heard of, even if they don't know the name: the barn raising. A timber frame this large, sometimes 100 feet long, couldn't be lifted into place by one family alone, so the entire community showed up. Dozens of men would physically lift and pin together massive pre-assembled wall sections, called bents, in a single coordinated day. Women cooked enough food to feed the entire crew. Children watched the literal frame of a neighbor's livelihood go up in an afternoon. It's worth sitting with that for a second. This wasn't construction as business transaction. It was a community event, a mutual aid system, and a structural engineering project happening simultaneously. And it still happens this way in Amish communities today, almost completely unchanged. The roof, almost always a simple gable shape, was framed afterward, and then the whole structure was finished with siding, typically wood board, sometimes later replaced with metal. And finally, often, those striking hex signs painted on the gable ends. These star, heart, and diamond motifs were brought over from German and Swiss tradition, with some scholars tracing the symbols back as far as the Bronze Age, originally believed to ward off bad luck or witchcraft. Today, most farmers will tell you they're decoration and tradition more than superstition, but they're one of the most recognizable visual signatures of this whole architectural style. Not every bank barn looks identical, and the differences actually tell you something about when and why a barn was built. Barn historian Robert Ensminger, who spent decades cataloging these structures, broke them into 3 main types. The standard Pennsylvania barn, built mainly between 1790 and 1890, is the most common, identified by a forebay built so both the front and back walls are the same height. Then there's the Schweitzer barn, sometimes spelled Switzer, which is considered the original version of the style, starting as a log structure built as early as 1730. You can spot one because its forebay makes the front and back walls uneven heights rather than symmetrical. And as farms grew and got more productive through the 1800s, families needed more storage and more stable space than the original design offered. So, you get the extended Pennsylvania barn, essentially a standard barn with additional space tacked onto the forebay side, the ramp side, or simply built taller with an extra story. It's literally a visible record of a farm's growing prosperity, frozen in timber and stone. This is the kind of detail that, once you know it, you can't stop noticing. Drive through Lancaster County or the Shenandoah Valley or parts of Ohio's Holmes County, and you can start reading a 150-year-old barn's construction history just by looking at the shape of its overhang. So, if this design is this clever, why doesn't anyone build like this anymore? The honest answer isn't a conspiracy. It's economics. A bank barn requires the right hillside to begin with. You can't build one efficiently on flat land without trucking in enormous amounts of fill dirt, which defeats the whole point. Modern American farms got bigger and increasingly mechanized through the 20th century, and a stone and timber structure sized for horses and hand tools often isn't sized right for a modern combine harvester or a fleet of tractors. Stone masonry and hand-cut timber framing are also slow and skill-intensive compared to a pole barn made from dimensional lumber and steel siding, which a small crew can put up in days rather than the weeks a barn raising with dozens of neighbors used to take. And modern HVAC, insulation, and electric lighting simply made the passive thermal benefits of earth-bermed construction less necessary for most commercial operations. Even though gallon for gallon of fuel and kilowatt for kilowatt of electricity, those passive benefits never actually went away. We didn't out-engineer the bank barn. We just stopped needing to be clever about energy because energy got cheap. Which is exactly why Amish and Old Order Mennonite communities are some of the last people still building and maintaining this style at scale, because they never stopped valuing a design that minimizes energy use, minimizes machinery dependence, and rewards community labor over individual capital. The barns weren't preserved by accident. They were preserved by a community that kept choosing the same values that built them in the first place. Here's the part that I think makes this story worth telling in 2026, and not just as nostalgia. Earth-sheltered construction, burying or berming part of a structure against the earth to stabilize its temperature, is having a real resurgence in sustainable architecture circles for exactly the same reason it worked in 1820. The thermal mass of soil is free, it's passive, it requires no maintenance, and it works whether or not the power grid is up. The bank barn was never primitive. It was a complete energy and labor optimization system built by people without electricity, who simply paid very close attention to gravity, soil temperature, and the cost of human effort, and then designed around those constraints instead of fighting them. You can still find thousands of these barns standing today across Pennsylvania, Ohio, Virginia, Indiana, and Ontario, some restored as event venues and horse stables, many still working farm buildings exactly as they were 2 centuries ago, especially across Amish and Old Order communities. Next time you're driving through farm country and you see a red barn tucked into a hillside with that little overhang on one side, you'll know exactly what you're looking at and exactly why someone built it that way 200 years ago. If you want more of these deep dives into the engineering and design knowledge that built rural America, the systems, the structures, the reasoning behind them, subscribe, because this is exactly the kind of thing this channel covers. And if there's a specific barn, building, or system from Amish or Old Order communities you want me to break down next, drop it in the comments. I read everyone. Thanks for watching.